Picture a world where death doesn't mark the end, but a crossroads in a vast quantum universe. It's a place where our understanding of life and death becomes a fascinating puzzle, inviting us to explore the mysterious connections between them. The idea of quantum immortality theory has gained attention recently, stirring up curiosity and discussions. In this exploration, we take a journey to understand this concept, looking into its origins, its connection to quantum mechanics, and an experiment that attempts to unravel its mysteries. In the scientific community, it's a topic of ongoing conversation, challenging our usual ideas about life and death. At its core, quantum immortality theory offers a fresh perspective on existence. It's based on puzzling notions like Schrödinger's cat and the intriguing many worlds interpretation of quantum mechanics. However, it also faces criticism for being difficult to test. Despite this, it calls on those eager to explore and promises to reveal the hidden aspects of our reality. Quantum immortality is an intriguing idea that links to the mysterious world of quantum physics. It's like a fascinating thought experiment. In the world of quantum mechanics, there's this concept called the many worlds interpretation. It suggests that for every choice you make, or every uncertain event that happens, there's a universe where each possible outcome occurs. So, let's say you find yourself in a risky situation, like playing a game where your life is at stake. According to quantum immortality, you always end up in a universe where you somehow manage to survive, no matter how slim the chances. From your perspective, you'll only ever experience the universe where you keep on living, even though there are many others where things turned out differently. It's like you're the main character in a never-ending story, where you always find a way to stay alive, even when it seems highly unlikely. This concept may seem like something out of a sci-fi movie, but it's a creative way to dive into the weird and wonderful world of quantum physics and how we think about life and death. It's a bit like being the lead character in your own epic adventure, where you never reach the end, even when the odds are stacked against you. So, quantum immortality is all about exploring the fascinating possibilities of quantum physics and how we perceive our existence. Schrödinger's cat experiment is a famous illustration of the peculiar and sometimes baffling nature of quantum mechanics. In this thought experiment devised by physicist Erwin Schrödinger in 1935, a cat is placed in a sealed box with a radioactive atom, a Geiger counter, a vial of poison, and a hammer. The experiment hinges on the unpredictable decay of the radioactive atom, which triggers the Geiger counter and, if detected, smashes the vial of poison, ultimately causing the death of the cat. However, due to the probabilistic nature of quantum mechanics, the radioactive atom exists in a superposition of decayed and undecayed states until observed. Until someone opens the box to look inside, the cat is considered both alive and dead at the same time, creating a paradox. Schrödinger's cat experiment relates to quantum mechanics and the many worlds theory. In the many worlds view, each quantum outcome leads to the creation of parallel universes. In this experiment, it means that the radioactive atom's decay results in one universe where the cat is alive and another where it's dead. Observers in each universe perceive different realities, resolving the paradox by suggesting that the cat is both alive and dead in separate branches of reality. This concept involves the observer, who experiences only one outcome while all possibilities occur simultaneously. Schrödinger's cat experiment illustrates the many worlds theory's approach to quantum superposition and the idea of multiple parallel universes splitting with each quantum event. So is there any evidence? Quantum immortality is a fascinating and controversial concept rooted in quantum mechanics and the many worlds interpretation. However, it's important to note that this idea remains largely speculative and there is no direct empirical evidence to support it. That being said, proponents of quantum immortality suggest some arguments and thought experiments that indirectly point to its existence. One of the key pillars of quantum immortality is the notion that the probabilistic nature of quantum mechanics allows for infinite possibilities. The uncertainty principle in quantum physics, for instance, suggests that we cannot precisely predict the outcome of certain events, This inherent indeterminacy provides a theoretical basis for the concept of quantum immortality. Proponents argue that in a multiverse where every possible outcome occurs, there will always be a universe in which an individual miraculously survives any life-threatening event. Another aspect of quantum mechanics that fuels the idea of quantum immortality is quantum superposition, a principle illustrated most famously in the double-slit experiment. This experiment demonstrates that particles, such as electrons, can exist in multiple states simultaneously until observed. Advocates of quantum immortality propose that conscious observers continually find themselves in branches of the multiverse, where they survive, as they can only perceive their own subjective experiences. The delayed choice quantum eraser experiment is a fascinating quantum physics experiment that challenges our understanding of the fundamental nature of reality. It explores the behavior of particles, like photons, in a setup that seemingly allows for decisions made in the future to influence events in the past. In this experiment, a photon is sent through a beam splitter, which splits it into two paths. The photon encounters a choice. It can either behave as a particle or as a wave. Depending on the path it takes, its behavior differs. However, what makes this experiment especially intriguing is that the choice of how the photon behaves can be delayed until after it has already passed through the beam splitter. In other words, the observer can decide whether to determine which path the photon took particle-like behavior or wave-like behavior after the photon has already passed through the beam splitter. The implications are profound. It suggests that the behavior of the photon is influenced by the observer's choice, made after the photon's interaction, blurring the lines between cause and effect. Proponents of quantum immortality use this experiment as an example of how the observer's future actions could influence events in the present, potentially connecting it to the idea that an observer's consciousness exists only in universes where they survive. Quantum immortality is met with numerous controversies and criticisms. Firstly, it relies heavily on the assumption that the many worlds interpretation is the correct interpretation of quantum mechanics, which remains a subject of debate among physicists. Additionally, it raises ethical concerns, as deliberately exposing oneself to potentially fatal events for the sake of immortality poses serious moral dilemmas. Moreover, critics argue that quantum immortality is fundamentally unprovable. Even if one were to experience a series of fortunate events, there is no way to confirm that these events are the result of quantum phenomena or simply a matter of extraordinary luck. This makes the hypothesis difficult to test or validate empirically. Anyway, what do you think? And have a good day.